Okay, let's look on this question. It says, under which conditions of pressure and density will a real gas approximate to an ideal gas? So you have probably learned that there is some assumptions that you need to do, you can do for an ideal gas. And these assumptions could be summarized to things about the pressure and the density. Let me try to explain it for you. Starting with pressure. So pressure, according to the ideal gas law, then you know that PV is equals to nRT. And if you isolate pressure, if you make pressure by itself as nRT divided by volume, then you can see that if you have N as a constant number of moles, the volume of the container as a constant, and R of course is a constant, so it is a constant, then pressure is proportional to the temperature of the gas. And the temperature is proportional to the speed of the individual molecules in the gas, according to this formula, 3/2 Boltzmann's constants times temperature. This is the average kinetic energy. And you can also calculate it as mv squared divided by 2. So for a gas with molecules of mass m, if you increase the temperature, you will increase the speed of the atoms or molecules. Now, we have said that in a gas the molecules collide elastic. And that is true when the atoms moves with quite slow speeds. Because if the speed of the molecules becomes very high, that is when temperature is very high, that means that the pressure is very high, then they can undergo fusion. That is what happens into our sun. So two molecules, when they collide, could be one new molecules. For instance, could two hydrogen molecule atoms collide and become eventually something with heavy hydrogen and eventually helium, like in our sun. And you know that the pressure in our sun is very high. And that cannot be the case for an ideal gas. If two molecules collide, we have fusion and it becomes a new subject into it, then it's not an ideal gas anymore. The atoms are supposed to collide elastic. That is, collide and bounce away from each other with the kinetic energy conserved. Therefore, the pressure needs to be low. With high pressure, they can get stuck into each other. Now, the density. And the density is actually seen as the number of moles divided with the volume. You know that it's the mass divided by volume. That's how we define density. But if we know the number of moles, then we can calculate, of course, the number of atoms, and we can calculate the mass of the atoms or molecules. And then divide by volume, and we have the density. Now, one of the assumptions for an ideal gas says that the volume of the particle, they should be seen as point particles. So they should be an individual particle as a point, and then there would be some big distance to the next molecule in the gas. So they will be separated with quite a big distance between them. So therefore the volume of the entire gas will be much bigger than the volume of individual molecules. If that is not the case, if the density is very big, so we have many more molecules, then they need to be close to each other. And if they are close to each other, there will be electric forces between the molecules. And when that happens, there will be a potential energy of the molecules because of that force. And in an ideal gas, there is no potential force between molecules. They only have kinetic energy, not any potential energy. Therefore, the density needs to be low. And then you see that's one option, option D, where that has to be true for both of them. Therefore, D is the correct answer. Okay.